Human brains evolve to understand a very specific, local reality. We navigate our lives using manageable metrics, like driving 60 kilometers down a highway or measuring our days in hours. But when you look up at the night sky, that hardwired intuition fails. You try to project those familiar earthly rules onto the stars, and the brain simply cannot process the gap between what you see and what is actually there. To truly comprehend the size of the universe, we have to travel outward until every tool, metric, and concept we rely on completely shatters. Grasping the scale of space requires an intellectual leap that forces the human mind well past its biological limits. Let's start with our standard ruler, the kilometer, and take our first step off Earth. At roughly 384,000 kilometers away, the detailed, cratered surface of our moon provides a familiar starting point. Even at this close proximity, the distance strains our earthly logic. If you could drive a car upward at a constant speed of 100 kilometers an hour, it would take you over 160 days straight to reach it. Move outward to our sun, and the gap widens to about 150 million kilometers. Light itself takes over 8 minutes to bridge the space between that fiery surface and our planet. Push further to our neighbor, Mars. The distance fluctuates greatly due to shifting orbital dynamics, but flying there in a commercial jet at its furthest distance would take over 50 years. By the time we reach the edge of our solar neighborhood, the ice giant Neptune sits roughly 4.5 billion kilometers away. At this point, the kilometer loses all utility. The numbers string out so long they become impossible to visualize, forcing astronomers to invent an entirely new standard to make sense of the math. This diagram illustrates a new standard, the astronomical unit. Instead of counting billions of kilometers, scientists call the Earth-Sun distance 1 AU. But when we project this tool to the Oort cloud at the edge of interstellar space, the measurement expands to a staggering 100,000 AU. Launched in 1977, Voyager 1 is our furthest physical outpost. It has been wandering for over 4 decades, crossing into this dark boundary zone over 22 billion kilometers away. In 1990, astronomer Carl Sagan famously requested that the probe turn its camera backward for one final photograph. From 6 billion kilometers out, Earth appeared as a fragile, pale blue pixel in the void. Even with the astronomical unit keeping our local system organized, reaching the heliopause proves the metric is already obsolete. The cosmic borders force us to abandon it for a much larger ruler. We must upgrade to the light year, the distance light travels in a single Earth year. To reach our closest neighboring star system, Alpha Centauri, we have to cross 4.4 light years of empty space. The gap is immense. If the Voyager spacecraft were headed there right now, traveling at 17 kilometers a second, it would take over 70,000 years to arrive. And that is just the star next door. Expand your view to our home galaxy, the Milky Way, and you are staring at a massive spiral disk spanning roughly 100,000 light-years in diameter. This graphic shows a tiny, glowing 100 light-year sphere nestled in one of the outer arms. This human radio bubble marks the absolute farthest extent of our broadcasts into the cosmos. Any civilization outside this exact sphere is entirely oblivious to our existence. The light year exposes the scope of our isolation, revealing the sum total of human civilization as a localized, virtually undetectable whisper in the cosmic wind. Stepping out into intergalactic space, our galaxy joins the local group. This cluster of over 50 galaxies stretches across a region 10 million light-years wide. Zoom out further, and that group merges into the colossal Virgo supercluster. Here, thousands of galaxies orbit one another, rendering individual stars conceptually meaningless. Finally, we arrive at our grand address, the Laniakea supercluster. This massive gravitational neighborhood contains the mass of 100 million billion suns, all flowing inward toward a dense, mysterious center, known as the Great Attractor. At this scale, we are no longer measuring discrete physical objects. We are mapping out the gravitational architecture of reality itself. This diagram illustrates the absolute limit of human sight, the observable universe, stretching a staggering 93 billion light-years across. But this creates an immediate paradox. Scientists know the universe is only 13.8 billion years old. How can a structure be 93 billion light-years wide if light has only had 13.8 billion years to travel? The answer is that the fabric of space itself has been actively expanding since the Big Bang. Rather than objects moving through a static void, the physical distance between them is continually stretching. This leads to a haunting consequence. Because space is expanding away from us faster than the speed of light, those distant galaxies are retreating permanently out of our view. Our attempt to measure the cosmos ultimately hits a hard physical limit. The universe is vast, but it is also a closed door, leaving humanity as an isolated story in a grand library we will never fully be able to read.